Hi, I am Kushagra and I have with me my colleague Abhit Mahajan. We are here to talk about patent portfolio management. Patent portfolio management can be done in multiple ways depending on an organization's requirements. For example, if you are looking to expand your patent portfolio, strategic filing or patent acquisitions can be performed for portfolio management. If you are looking to monetize your patent portfolio, patent licensing can be done. While if you are looking to optimize your patent portfolio, patent pruning analysis can be performed. We at Sagacious have been managing patent portfolios for multiple Fortune 500 clients. One such client is one of the largest companies in the semiconductor domain. For this client, we are performing patent pruning analysis. Patent maintenance fees are to be paid after 3.5 years, 7.5 years, and 11.5 years after a grant of a patent. These fees increase with each annuity. Therefore, it's very important to identify low value assets to optimize your portfolio before, especially the third annuity. So, Abhit, while performing such large portfolios, what are the key aspects that we keep in mind to ensure accuracy as well as efficiency?
First we try to understand the field of invention, advantages of the invention, and identify the problem which the invention is going to solve. We further identify that is there any existing solution currently available or research in the field of invention to solve that problem. We also check the potential applications of various products and technologies. By using these steps, we ensure quality and accuracy in our analysis.
So, for exhaustiveness, we look to identify what are other key players working on, and for ensuring accuracy, we try to identify what particular aspect of the invention are we trying to cover. So, could you provide us some examples of the technologies that we work on?
Yes. So the first one is the image sensors, and we have front illuminated structure and the back illuminated structure. In the front illuminated structure, the incident light falls on the photodiode by passing through the metal wiring or the interconnections. But in back illuminated structures, the incident light directly falls on the photodiode, so that large number of photons gets converted into electrons, resulting in high sensitivity. So the next one is the semiconductor packaging, and we have 2.5D IC package and 3D IC package. In 2.5D IC package, we can see that the memory and the logic die are placed adjacent to each other, and these are interconnected through the interposer. And in 3D IC package, the memory die and the logic die are placed on top of each other, and these are connected through silicon vias. Another important semiconductor packaging is the fan out package on package, in which the top package is placed on the bottom package and the input output connections are fanned out of the chip surface. Next one are the field effect transistors, and we have planar transistors and the non-planar transistors. In non-planar transistors, we have FinFETs and the gate all around transistors. So these transistors differ from each other in the way that the gate control. As we can see, the in the gate all around transistors, the gate completely wraps the channel, and in FinFET, the gate wraps three sides of the channel. By understanding the differences in these structures, we can easily understand and classify the patents.
So, this classification and identification of which particular field the patent is related to helps us in narrowing our search to the most relevant aspect or structure that is present in the industry. So, Abhit, what are some other key parameters that we look at or analyze while performing pruning analysis?
One such is multi-level characterization. So we classify each patent in the portfolio in the first and second levels of categories. For example, say we have a patent related to FinFET technology. So we try to go deeper into the technology to find which technology it belongs. Example, it belongs to gate structure, it belongs to FinFET, fin structure, source drain, channel strain, or the air gaps. So this multi-level characterization ensures that one can easily identify a set of relevant patents that pertains to a specific technology. Further, we rate each patent in two more aspects related to detectability and the industry usage. So, detectability scoring is based on whether all the claim elements can be identified from product literature or whether reverse engineering might be required. Another key aspect here is the industry usage, and we provide scoring, and that is based on the detailed analysis for the patents. And we do not restrict ourselves to companies' documentation. While we use IEEE papers, journals, tech blogs, reverse engineering images to ensure the analysis. We also recommend reverse engineering for some cases where novelty or indication of novelty can be identified. So, by using these techniques, high value assets can be identified and recommended for EUs to help in licensing opportunities.
Absolutely. So, one of the most important aspects that we consider is not restricting ourselves to current industry usage. We also consider future applicability of the technologies. For example, gate all around FETs currently are not being used widely in the industry. However, there is a lot of ongoing research in the field by key players, and we believe keeping such parts of patent portfolios helps and would be relevant in the future for various kind of projects like licensing projects. Each year, we receive a list of around 1,000 patents from our client, and we perform patent pruning analysis on the same, based on which around 20 to 30% of the patent portfolio is abandoned. This saves nearly 1.5 million USD in maintenance fee payments. For future projects, we can use technology tags to identify a subset of portfolio. Similarly, the technology tags can be used to identify areas for divestiture. There are parameters which can be modified based on the project requirements. Thank you for watching, and we will catch you in the next one.